Now let's look at the overall system. So what we designed in this project is a simple interface that non-technical people can use, something that they can actually use in a mission critical environment. You just want to simplify it. You want to be able to quickly find your area and limit the area of search. Now this depends on the country. So every country is different. And some countries, you can get all the technical information of the sites from the regulator. In other countries, maybe you need to rely on some complementary information from the carrier. Now in this example here with Korea, the regulator is the one making the technical parameters, all the sites, the antennas and so on, transmission power, frequency available to the agency, but the carrier here is only providing the connected, non-connected sites, okay, by correlating the IMEI of the handset with the cells, and then you can find out what is the most recent connected cells. So this information are connected using SQL database, in fact. So we collect this information and then we process this information, and then we can apply some default templates for missing parameters. So some checking for the parameters, some quality checking done by this interface. And then if the information are not within a certain tolerance, then we can apply some default templates, such as antenna pattern, for example, may not be available. So this simplified interface will automatically engage our planning tool, HTZ, does all the calculations, all the computations, and then finalize it, and then give you one final outcome in a Google Earth format. As a presentation layer, you can display coverage analysis and also the optimized search area. So we're going to rely on all this information. HTZ integration was done using the API. So we're going to talk about this API. So from the regulator or the carrier, we need some basic information, and trust me, it's not hard. So we can get a lot of information from them, and if some information not there, we could use some templates. So we need to have the antenna azimuth. Where is it pointing to? The sector azimuth, the tilting. If there's any mechanical tilt or electrical tilt embedded, we could also capture this information. We need to capture transmission power, antenna gain, transmission frequency, the antenna height, and bandwidth. And we are importing them from a technical database, and then we could model this in a planning tool. Okay, so some of the information you need are site coordinates, transmission power, frequency, and tilting, antenna height, and so on. So now we're going to focus on this simplified GUI and talk about the sequence of configuration or functions that need to be established in order to produce the final outcome. Step number 1 in the simplified GUI, location. So first we need to search by address or coordinates. So the idea is that to enter the name of the park, for example, national park, or nearest business, or maybe coordinates, you can put the coordinates directly. So the idea is to specify where is the location, the target location first. And from that location, of course, you can do culling, and then you can do further analysis. Second, we can filter by operator. Third, you can do technology restrictions. For example, you want to restrict your culling to 2G or 3G or 4G or 5G. So reduce the number of sites produced in the process. Step number 4, you need to set the status. So this status could be done automatically or manually, okay, depending on your coordination level with the operators. Usually operators are not very keen to provide API access or something like that. So the idea is that they will give you a list of cell IDs, and they will give you the status, if it is connected or not connected. So this information will be handy. You can update the status of the site or the sites. Then we could select default templates for missing technical parameters. So the GUI will automatically do some validation, and then we'll use some default templates. So these default templates can be set up for every country or for every operator. That will help enhance also the accuracy, and also substitute any missing parameters. Step number 6, we run the analysis. So analysis, you can you have buttons that you can choose. You can run analysis for coverage, or for server, which is dominant server, for overlap, or for search area directly. Finally, you can export this to Google Earth and then present the outcome. So this is the workflow for the solution. This is how the solution look like. So for the user, that's all what you see. Okay, this is the GUI, and you can do everything from here. You don't need to run a sophisticated tool. You don't need to have a training on a planning tool. You don't have to be RF engineer to do the job. So this is in Korean, like I said, because this product was developed for the Korean market. On the left-hand side, this is where you choose your search, the type of search you want to do, search by address or search by coordinates. And then here you can choose the operator you want to limit your search to, SKT, Telecom, Korea Telecom, or LGT. And here you can even do also restrictions by technology. So here is your criteria, or your culling criteria. Here you can do the coverage, you can do the analysis, the coverage analysis directly. You can do composite coverage, best server, overlap. You can do search area optimization. So this is a single button. So you can just click the button you want, and then the software or the solution will automatically launch HTZ, do the calculations, and then present the outcome. Here we have some shortcuts for different type of analysis you could do in the process, like setting up external database and so on. And this is the outcome. So these are the list of sites found in that area. So in that area, we found 1, 2, 3, 4, 5, 6, 7 sites. Okay, so that's the frequency, longitude, latitude, and this is site ID 5330 and so on. And here you can search the table. So you can search for specific cell ID. You can search the outcome for specific cell ID. So you can update the status, which is the first step in the culling. You choose the type of search by address, for example, and then you type the address you want to search, and then you choose the operator. You might want to choose all the operators, and then technology, and then you hit search, and then the software will return the outcome. And then you can go and update the status of that site. You can say connected or disconnected. So you can filter the ones that are connected. So you can filter them and then change the status to connected. Once you finish your culling, you finish your status update, now you can proceed to the analysis directly. So in the analysis, once you click on that button, it will automatically run a certain script or a certain workflow, which will engage HTZ, and HTZ will do all the computations and then present the outcome to Google Earth. It can produce composite coverage for connected, best server for connected, and for best server for disconnected, and so on. So it can produce the analysis for connected, disconnected, and for the search area, and so on. So let me run a demo here to show you how it works. So this is the interface. It's going to search for an area on the left-hand side. There's auto-completion to help you locate the area. This is it chooses not to do any filtering, and then it's returning all the sites. Now he's searching for a specific site name in the outcome, and then you could update parameters here. So it's changing now status to connected. So he found a site which is the victim is connected to. Is updating the status, connected and disconnected. This is giving the freedom also to choose antenna, default antenna from the templates. So now you run the analysis, and you see it will automatically engage the planning tool HTZ, opening the map for the country, running coverage predictions. So this is fully automated. The software will automatically generate the base stations, get the configuration, do coverage computation. So now, after coverage computation is done, it will do coverage analysis, which is the composite coverage, the best server, overlap, and the search area. And it would export this into a TIFF format and to Google Earth, like KMZ format. So you see there's no interaction here between the user and the tool. The tool will just autonomously execute the task. Now we could automatically run Google Earth and then present the outcome, or it could be published somewhere else. So now it's going to add this information to Google Earth to present the outcome. I'm going to run a local example as well to help you further understand this. So this is an example of a project with automation script. So automation script is prepared here. So these execution command lines are usually executed by the application, by the customized application. In that case, I'm just going to run it as a script. So in the output section, I've got nothing here. I'm going to delete everything. So there's no output now, and the input to this is digital terrain over South Korea, and I've got some settings, default settings, and I've got some input such as HTZ. Access database. So I'm going to run the script now. So launching HTZ, importing the sites, connected and disconnected, doing coverage prediction very quickly, saving the coverage, now loading the coverage and doing the computation analysis. This is the composite coverage. So the first one was the combined overlap, which is the optimized search area. Second one is just reception. This is the best server. So all this information, all this analysis are very useful to understand your search area and to prioritize your search area. Okay, this is done. Now let's look at the output again. Here we go. So I'm going to run now Google Earth. So I'm going to drag the KMZs. So you see we have TIFF file, which is generic format, accepted by many JS software. All right, so I'm going to shut down the analysis and then do it one by one. So this is the coverage for the site of interest. This is the coverage, so the reception area. This is the best server. This is the best server. And this is the normal overlap. That's overlap for the 3 sites or the 3 cells in the area. And this is finally the combined coverage, which is the search area. So this is the search area based on the knowledge of connected and disconnected sites. So this is the search area, just the pink, based on the reception. So this was calculated based on the overlap of the 3 cells and based on also the neighboring best server in the area. So let's continue. Now, search area on portable devices. So in fact, you could export your search area or your coverage analysis entirely, which is the best server, composite, and so on. You can export this to portable devices or web-enabled devices such as an iPad or a phone or tablet or laptop, whatever. So any device with a web browser, you could actually go and publish that coverage there. So if it's a team, if it's a team working on this, it would be useful, for example, to exchange the coverage in a platform, and then be able to check your location against that search area. So there's a video online if somebody wants to watch it to learn more about this product. So this product is it's controlled by user access. So someone could supply someone could access the system with the credentials. So I'll show you how it works. So go to the coverage. Here we go. You can search by address. Okay, so you can has autocomplete feature. So the different analysis can be automatically added to that tray here, and then you can see the legend here, and you can zoom in and zoom out in the area. So this product is called HTZ WebView. So it's only used to publish the coverage analysis that you produce with the HTZ. It can be published on the web, and they can be available to large audience or to a number of people. So in conclusion, the technical knowledge of the telco sites help optimize search and rescue area. So adding this information or utilizing the technical parameters of telco network can further help you establish a coverage more accurately, and then it can optimize your search area. The tool's complexity and significant inputs can be simplified. So I know there's a lot of agencies, especially non-technical users, have a massive concern about complexity of such tools and the sheer number of technical parameters needed. So this is not a problem. It can be simplified, and it could be packaged in a nice interface with minimal input required from user, and also no intervention. So you could do an interface to local regulator or carriers or local database. So if the exchange between the agency and the regulator or the carrier is happening in an offline fashion, for example, file transfers, database transfers, and so on, yes, this is sufficient. It is possible to establish a format, exchange format, and then that solution can utilize that exchange format to avoid manual process. So for any missing parameters or incomplete parameters, because I know a lot of people or a lot of agencies share that concern, is that telcos or regulators do not keep an accurate picture of or accurate technical parameters of the sites. This is not a problem as well, because usually you have a certain, for example, on a specific band you use specific antenna. Transmission power is usually in a certain range. So it is possible to populate or to complement the technical parameters by relying on templates. So overall, this achieve more accurate coverage predictions. So more accurate cell coverage prediction thanks to the terrain, the usage of the terrain, the clutter, and the propagation engine. It's all helping to further enhance or reduce the search area. So thank you guys for your time. This is for today, for that webinar, and we will be happy to receive any clarifications or questions you might have. Thank you.